Good morning, good afternoon, everyone. Thanks again for joining. My name is Jawahar, and I would like to welcome you to our Afternoon Coffee with Legrand show. So this week, we have a great guest joining us. He's one of our great customers, Harmail Singh, and he comes from Nutanix. I hesitated a little because I know him from Groupon, and now he's at Nutanix. He's going to talk about how to build a data center that keeps on giving. Basically, it's not a one-time thing. You put a lot of planning into it, but you reap the rewards over and over again. So he's the Senior Director of Global Platforms Operations at Nutanix, and he wears multiple hats, and two of which are very interesting in my perspective. He's a technical architect, so he understands the ins and outs of data centers, but also he wears the business hat because everything needs to make financial and business sense. So without further ado, I'm going to turn it over to Harmail. Hey, Harmail, how are you?
I'm good, Jawahar. Thanks. Great to be here. I hope everyone is, doing well, keeping safe, and staying healthy given the circumstances. But excited to have this conversation a little bit about, the thinking that went into architecting our data center and why we chose to do what we did. So I'm excited about the conversation.
Absolutely. Yeah, you said it well. I mean, it's these are tough times. We are not in normal circumstances. We have a pandemic going on, and today happens to be a day we are reflecting as a country who we are, our identity. So again, thanks everyone for joining, and thank you, Harmail, for joining. So I'll ask you about your journey into Nutanix. Like, what brought you into Nutanix, and what was your first challenge when you got there?
Yeah, absolutely. Give me a quick second. I'll share some pictures as we're having the conversation as well to let folks see some of the processes that went in.
And I'm sure some of our viewers have seen the video that you shared on LinkedIn with us, and that was really one of the beautiful data centers I've seen.
No, thank you. I appreciate that. So what you're seeing behind me is really how the data center build out started, but I'll give you a background story of how we ended up doing what we ended up doing. So, excuse me. So the challenge for Nutanix, like most hot startups in the Valley, was Nutanix grew up quickly, right? The constraint for the data center infrastructure team at the time was they needed to deploy gear quickly and make it available for engineers to consume. And obviously consumption had to be ASAP so they can do the best they could to meet the demand of the engineering teams. So prior to me joining, Nutanix had multiple retail co-locations and one wholesale data center location, all within the Bay Area. Which was fine as the company was growing and scaling, but by 2018, Nutanix had reached a chasm where they needed a more refined and scalable and economically efficient data center strategy. So the challenge posed to me by the CIO was, we currently have a 1.5 megawatt deployment. We're growing really quickly. We need a more resilient environment with 100% availability. It has to be designed to be customer facing for executive briefings. So make it look cool, have it be modern, make it innovative, do something that no one has done before. And of course, the icing on the cake was, like, as most of you already know, is she says, you're already 6 months behind, so get to it, and remember to stay under budget, but don't forget all that financial analysis such as TCO, ROI, IRR, NPV. So really not one to back down from the challenge. I joined Nutanix, and here we are today talking about our data center design. So as you guys can see, obviously, I made the cut. I survived. I'm going on 2.5 years being at Nutanix. So it's been a fun ride so far. So some of the process that went into designing the data center really started with me interviewing all the tenants of the current data centers. I interviewed all the primary contacts, the secondary, the tertiary contacts, of course, all being engineering. From there, I gathered a deep understanding of their current pain points and what their expectations were for a new data center design. What were they essentially looking for? And at the same time, I started to do some data gathering analysis exercise to understand the current data center environments, right? From a power, cooling, networking, consumption, deployment models. And additionally, at the same time, I started reaching out to my network in the data center world to understand the latest and greatest technologies, design strategies, and where the market was heading from a data center perspective as well. And I wasn't done there. In addition, I started vetting out data center providers within the Bay Area, all along the West Coast, North, Southwest, to see who's providing the more efficient and innovative facility designs, evaluating rent, power, and performance metrics. So the culmination of all that background work, the homework, is what we're here to talk about today. And I hope that kind of helps to paint a picture of where things started and kind of what led to what I'm showing you guys here.
That gives us a really good background on the actual challenge that you faced when you got into Nutanix. So you mentioned you searched pretty much across the entire West Coast to look for a location. But if this is your development environment, why look beyond the Bay Area to begin with? Why, this is where your engineers are, this is where your clients are. Why look beyond the Bay Area?
Well, for me, it was the understanding that I got from the engineering team to kind of come to terms as to which the question I pose back to engineers and the executive management team is, why do we actually need to be in the Bay Area? We're not a latency sensitive application e-commerce type platform where every millisecond equates to dollars lost by latency. For us, it's a software development platform, and of course, it's a production software development platform, but not the whole platform is customer facing and not like latency centric as well. So really, there was no need for us to be in the Bay Area for the development platform. There was a need for us to be in the Bay Area from a hardware qualification and a software qualification standpoint. So hence, we actually ended up executing on a multi-data center strategy across the West Coast, where we migrated a couple of data centers out of California, but we did end up keeping one in the Bay Area just for, like I mentioned, the hardware qualification.
Okay. So I see a lot of Legrand products that I can recognize in the pictures. Tell us more about like how we started the journey with you, and I mean, how did we help in terms of realizing the vision that you had for the data center? Because this is definitely different from most of the places that we have worked in.
Yeah, absolutely. Like I mentioned earlier, I started gathering engineering requirements. I collected data from our current environment, started to understand market innovation, vetting out DC providers to see what they're capable of supporting. Essentially, this was a massive puzzle. All the right pieces had to come together and align for the whole project to work per my CIO's original ask. And one of the foundational questions that really shaped the strategy was that led to the entire design was, what are the big boys, Facebook, Google, Apple, Amazon doing? How can we take advantage of some of their best practices in our environment? Of course, we don't operate at the scale that they do. They're, multi-megawatts, hundreds of megawatts deployments. We're essentially, a 2.5 megawatt scaling up to probably like a 3.54 megawatt type of a deployment. So, having those conversations, that's where someone that Jawahar, and our common friend,
Mhm.
our industry expert, the power genius, John Van Hoos, he kind of checked into the game, and we really just rolled up our sleeves, and it almost felt like we're back in like high school doing AP math. Like we really dug deep into power, cooling analysis, data center capacity, the growth rate, the workloads, the consumption run rate, resiliency requirements, financial economics. Like, how do we design an innovative model that was financially positive? And this is where we kind of gave up and said it would be easier just for us to outsource than wreck our brains on this, right? Because honestly, it was a lot of analysis and a lot of deep math. But this is actually where the fun began and the puzzle started to come together. So between both of us, we already had a fairly deep understanding of current market. The current deployment model was pretty standard at 400 amp busway, 208 volt power. But in challenging John was like, well, how do we get to 800 amp busway in a 415 volt power model? Can we
Mhm.
do it at our scale? Is there a bare minimum threshold that we have to have, such as like 5 megawatts or 10 megawatts? Is that where it starts to make financial sense? We wanted a data center provider to cool at minimum 17.3 kilowatts per rack and be able to scale up to like 34 kilowatts per rack as well. And then that became one of the vetting criterias as well, right? We wanted a provider that can handle a rack size of 52 U's and 30-inch wide racks and 48-inch deep racks that weighed 3,000 plus pounds. So in that situation, like a lot of data centers had to be slab, or they had to have these really heavy duty tiles as well. We wanted hot aisle containment. We, because of the density of our environment, which we're running 250 kilowatts per 16 racks.
Wow.
That's dense, right? We're running almost 350 servers in the 16 racks. In a traditional environment, that would equate to about 50 racks just to handle that density, right? So we needed a partner
Easily.
that can cool that capacity. We wanted to push the compute density of the rack to 92 nodes. The way that we structured our racks is, they're 52 U high. The traditional industry standard is about 45 U. So we took the additional U's, allocated the top portion of the rack to networking, but majority of the rack, 46 U's down, ended up being for compute, as you guys can see in the pictures. So that's 23 2U servers with 4 nodes in them. So that's 92 servers, essentially 1U servers in a 46U rack. And we wanted the most efficient PUE. A lot of the industry standard for PUE is 1.3, 1.4. And we just weren't comfortable with that. We wanted to challenge the model. So we went out and sought out data center providers that had the most efficient PUE, where we're getting 1.15, 1.18 PUE across a few of our data center providers now. So that's really what how the evolution of the design started, and where we ended up, and how we ended up finding the right partners because of this deep list of criteria that we had for them to meet our requirements, essentially.
That's an impressive PUE number. And now I can kind of understand, maybe that's why, I mean, I haven't been in your data center yet. Hopefully when the lockdown ends, maybe I can, one day get over and check it out. But John has been there many times, as you said, and he used to say the hot aisles are extremely hot. It's almost like you may pass out. Is that, I mean, now I can kind of understand how you get the PUE that you just mentioned. Um, so tell us more about the temperature that you're running this at. It seems like extremely high, even for a hot aisle. How do people work in it? I mean,
Yeah, no, that's interesting. So the temperatures, they get up there 100, 105 to 120. currently, and we're actually even trying to increase that, probably get it to 130 to 140 by increasing the workloads and maximizing the efficiency and utilization of the servers. So originally when we're designing this, we joked that we might have to get some, like, NASA astronaut suits for our data center operations team, just so they can go into the hot aisle to do the work. But no, fortunately, the data center providers, they're nice. They'll let us leave the containment doors open and get some cold air as the team's working in there. Obviously, it drops the PUE down, but health and safety of our employees is a lot more important than PUE. But we chose the Legrand solution because it's really multifaceted, right? And it was all built on economies of scale perspective as well. The breadth of this project was to innovate, it had to be cost efficient, it had to be customer facing, and it had to be delivered ASAP. And Legrand met the dimensional and structural criteria for the racks, the PDUs, the busway, and they said they can deliver upon the agreed upon timeframe as well. So for me, it was like, great, if any issues, there's one person to call up and yell at, essentially, if anything were to go wrong, rather than having multiple providers to chase down. Mm-hmm. And besides the the power profiles and the rack dimensions, the other intriguing aspect, like we talked about, is really the hot aisle containment. Is if we're pushing temperatures of 110 to 140, how do you essentially cool it? So as you guys just saw in that last picture, the containment was a central part of this solution. Is can we find a containment solution that can handle that heat temperature and at the same time be cost efficient and look modern and stylish as well? The Legrand solution solved multiple problems. It definitely was modern. It's an innovative design. It checks off my CIO's requirements as make it sleek, make it cool, so customers come in and are wowed by it. And second, it was really easy to install, and that could have been a real big challenge as you're looking at the busways there. Like trying to install the containment around the busway gets tricky, but with the line solution, it was actually really easy to install. And really, it was that easy. The data center provider is actually looking to make it their default deployment solution in all of their locations. And at the same time, it was financially beneficial as well, right? Economically, it's not gonna strain the wallet. When the whole project was around economies of scale, so hence we're able to leverage the size of the deployment to really drive the cost as well.
That's a great segue into what I had as the next thing for you in terms of the return. Like I said in the early introduction, you're not doing things just because it's cool, but you also see to that this makes business sense and financial sense. So as much as possible, if you can share some of those numbers with us as to, even though your CIO said basically don't worry about it right now, just get it done and get it done in a way where we can demonstrate and show this off, which I can see as well. You have the green and blue Nutanix colors on the busways even. But how do you? So what did you realize as a result of all the design work that went into it in terms of ROI or anything else?
Yeah, I mean, as you know, I can't specifically get into the direct financials being a publicly traded company, but the hyper dense design optimized for vertical instead of horizontal deployment netted us about a 68% lower cost on OpEx and on CapEx. Like it said, it's 50 racks versus 16 racks in a single row. So the size of the environment, it's 250 racks versus 160 racks essentially. So you can just imagine the savings from not having to procure additional real estate, procure additional cabling and infrastructure, and just all that cost gets reduced, right? Deploying the higher amperage and voltage busway resulted in about 30% savings as well. As you guys can see, we don't have tap cans dedicated for each rack. We're actually sharing and we're crossing. So no rack is actually getting power that's only from a side or a B side. They are crisscrossed, and they're completely independent. So if like one portion of the tap can were to go down, it necessarily doesn't affect the second portion of which is supports as the B side for the other rack. So there's a lot of savings in that because it's a 800 amp 415 volt design. We're actually able to save a lot on the PDU cost as well because of the topology of the PDUs. We didn't have to go 60 amp. We're able to go 30 amp 415 volt 3-phase. So savings in that. And of course, you know, having that strategy and the mindset of not having to be in the Bay Area and not having to pay these high real estate costs out here, the rent and of obviously PG&E power or even SVP power, we're able to take advantage of lower rent and power cost outside of California, and that was a big driver also in the strategy. And the other thing, you know, obviously, what do we get out of this? Since the deployment, particularly the one that we're showing right now, we've had 100% uptime from a data center perspective. Obviously, logically, there's been issues internally or something like that, you know, where we had an ISP issue or some misconfiguration perhaps. But from a data center perspective, it's just been amazing to see this environment available 100% for the engineering staff and ultimately improving their productivity. And that was one of the major gains of this project itself.
Understood, and thanks for sharing those numbers as well. I know it's a tricky topic. Maybe if people are interested, they can reach out to you and sign some NDA. Maybe you can help them with some of the data.
Yeah, absolutely.
Yeah. So that brings us to, you know, I was just checking if we have any questions from the audience while we were chatting. I see a couple. So maybe I'll start with them, and then if we still have some time, I would like you to show the video that you shared on LinkedIn, because I think that was an awesome video to for everyone to see. So the first one that I see here is was power redundancy a factor in the design, or was it not a concern since it's a development site?
No, power redundancy was a huge factor. The entire power redundancy, like as you see in the blue and the green, they're completely separate lines, all the way back to the substation that's on site. So there's no overlap at all. Hence, we've had the 100% uptime. We're able to do maintenance on A side or B side and not impact the environment at all. So absolutely, that was one of the essential components of this design.
And that tells us how you can assure 100% uptime as well.
Yeah.
So the follow-up question on that was it being supplied at the server PSU level, that is 208 volts, 30 amps? I'm not
at the
100% sure of the question, but
yeah, at the server level, it would be 415 3-phase 30 amp, which, you know, the PSUs are able to handle. But the entire model consisted of 415 volt to take advantage of the economies in this design. Essentially, if we were to stick with the 208, then the power model would have been much different. It would have been a 208 3-phase 60 amp to get to that 17.3 kilowatts per rack desired state that we wanted. And hopefully that helps to clarify. If not, please ping me on LinkedIn. Happy to engage a little bit further as well.
that'll be great. Yeah, so I think if I put my thinking hat on, so that'll be 415 at the busway level, then at the PDU level, the inlet is 415, but at the outlet level, what's going into the PSU would be 208 single phase. So hopefully that clarifies it further. Then there's another question on the server nodes. I think they're referring to the picture you're showing now. Are these custom-built server nodes or rebranded hardware?
So this is super micro hardware essentially, rebranded as Nutanix. But we're actually out of the hardware game. We're purely a software company. So for us at the moment, it really doesn't matter if you're running Dell or if you're running with HPE or you're running Supermicro, any one of the other manufacturers. Really agnostic to it. It just so happens in this data center when we're designing, it was all built on Supermicro.
Got it. I see something that came up as a question, but it's a funny comment. Those temperatures in your hot aisle can kill COVID bugs. If you go, especially 140.
Absolutely. We don't need social distancing in there. That's how we quarantine anybody that wants to come and visit the data center. We just throw them in the hot aisle for 5 minutes or something like that.
So there are a couple of more questions that came up recently. So did you derate the busway for high temperature? I think that's a great question there.
Do we derate the busway for, sorry, what?
For high temperature.
That would be more of a question for you guys, Van Hoos, particularly. I don't know. I don't know if we did. I think it was designed to handle that. We definitely had a conversation more at the network cabling and power cabling perspective.
Mm-hmm.
Not so much at the busway perspective if it can handle those high temperatures.
Yeah.
There's been no issues. I don't think we've had a single tap can failure. So the busway has been able to handle the heat without any issues at all.
Yeah, the rating that we generally go for is 140 Fahrenheit. So this is well within the range. I know you're pushing it close to that, but that shouldn't be a problem.
So that's gonna.
The answer I would say is, yeah,
I was gonna
go
say
ahead.
that'll be an interesting case study once we do start running up against that. We should have you guys come in and do some testing.
Absolutely. We'll be happy to do that. Yeah, so the answer to that question is no, there isn't any derating done because of the higher temperatures, because we can handle that. Then there is another question that's, I think the question was about 480-277 versus 415-208. So I think we should just clarify. The setup that Harmail has is a 415 at the busway and the PDU level, and 208 at the server level. And it's not the 480-277 that is common in the OCP community.
Yeah.
The other question is, can you speak to the cooling system design, please?
The cooling system design, obviously it's a fan wall cooling system. They're called Delta Cubes. We have 9 of those square fan walls, basically cooling the entire environment. It really is recirculated air as well. A lot of it's outside condensation, refurbishment. So the fans rev up depending on the amount of hot air that's generated. That flows back into the coils in the back of the fan walls, and that determines how fast they spin up or spin down. And then that ultimately gets cooled up on the towers. It's about as deep as I can go into it. If you need further information about that, then I can put you in touch with our data center providers.
Okay. Yeah, there's a slight clarification on the 415. 415 will give you 230 at the server level, not 208. So that was my bad. So I think that's all the question we have right now. So if you we're at the 11:30 mark, but if you still have a couple minutes, Harmail, I would love to see that video. So
sure, I can quickly. It's just a short video. You can spin that up.
And like Harmail said earlier, if you have further questions, he's happy to connect with you on LinkedIn. So LinkedIn would be a better way to connect with him. And likewise, if you have questions on the Legrand products, please reach out to us. We'll be happy to answer those. So Harmail, looks like we're still not done with the voltage here. I just got another comment that it's actually 240 at 415 volts. It's 230 at 400 volts. So
Van Hoos should
clearly,
be able
I
to
think
clarify that. I think Van Hoos knows it for sure.
we saw the fan wall that you mentioned earlier on one side. So that's one side of the aisle. So there's no door on one side, I guess.
Yeah, there's doors on both sides. Just the fan wall is on one side. Yeah.
Fan wall. Okay.
All right, that was it.
That's awesome. Thanks again, Harmail. Appreciate your joining, and we'll, like I said, hopefully I'll be at your data center one day to see this in person. But thanks for taking this time and chatting with us. I would like to also thank all the audience that joined us.
Absolutely. No, thank you for having me. It's been great. Definitely welcome to the data center once we're able to travel again. And if we have any customers or potential customers out there as well, if you guys are interested in a tour of the data center, please just reach out.
Awesome. That's a great offer. Thank you so much.
No problem.
See you soon.
All right. Thank you. Have a great day, everyone.
Take care.